Hello everyone, welcome back to my channel. Today let's go over a Leetcode hard question that I just solved on my own. So I'm actually really happy about this because I struggled with this quite a while. And then I was able to try a couple things and I finally got it without any assistance. So again, I'm pretty proud to show you. This one is a binary search question. It's not too hard once you realize the pattern, but basically the ask is really easy, right? You have this array and you have this target. This appears at index 2 and 5. You just want to return the lesser index. Here it doesn't appear, so return -1. Pretty easy, right? So the first thing I tried was a brute force approach. Basically, let's just go I is 0 while I is less than mountain ARR dot length, right? I plus equals to 1, just iterating over. And then at any point, if mountain array dot get of I, that value is equal to target, then we can just return I, right? Because that's the left to right, the leftmost index with that value. And then at the end, if we don't find it, then we just return -1 at any point. So we submit this. That's going to time out because you're only allowed 100 calls. So let's first make some observations. You notice here that the biggest element, everything to the left is smaller and everything to the right is smaller. So it's ascending here, ascending, and then descending. Ascending and descending. That helps us a lot because we can just do a flipped binary search like this and then a normal binary search like this. Same here and here. So first, the task is let's try to find the peak element, the biggest element, right? So we just do that by mountain array dot length -1 while left is less than or equal to right or less than right. In this case, we can just say mid is left plus right divided by 2. So we're just going to compare these, and then to find the biggest element, basically just as long as this is less than this, we shrink this. If this is less than this, then we move the right pointer, right? We're just trying to find the biggest element that we can and eliminate all the small elements that we already know. So if mountain ARR dot get left is less than mountain ARR dot get right, then in that case, left equals mid plus 1, else right equals mid -1. And let's print mid. 0, 1, 2, 3. And then also, if mid plus 1 is less than mountain ARR dot length, print mid plus 1. If mid -1 is less than mountain ARR dot length, print mid -1. And you'll notice this encompasses the index at where the largest element will occur. So here it's 0, 1, 2, 3, 4. 4. That's good. Here it's going to be 0, 1, 2, 3. Cool. So now we have to keep track of the index where the biggest element appears. So let's call this, the value is mountain ARR.get mid. Let's call this value is mountain ARR.get mid +1. Equals mountain ARR.get mid -1. And then let's have a sorted list because we want to keep track of the value. So sl.add the value and then also the index, right? So same thing here. And here, again, we're just trying the peak. So let's print SL. Cool. So now we have the peak element and where it appears 0, 1, 2, 3, 4. Let's see here. So the value 5 is at index 0, 1, 2, 3, 4. Oh, sorry, mid +1, mid -1. Reflect that. Cool. So index 5 is at index 4. 4 is at index 3. Great. So now we can just say the biggest index location is SL of -1 of -1, and the biggest value, the peak value, which is what we want, is at SL of -1 of 0. which is this. So now that we have that, this makes our life a lot easier because we can just say, cool. So now we can say if target is less than or equal to the peak value, then we have to binary search up to here and then up to here, right? Or up to here and then up to here, since this is the peak, this is the target. It's either on this side or on this side. Same here, if it is at all. So answer obviously is going to be we're trying to minimize something. So first, let's binary search the left side. So left, right equals 0 up to peak or peak index. Let's call this that, because we already know that's going to be 3, 0, 1, 2, 3. Peak index, while left is less than or equal to right, mid equals left plus right divided by 2. At any point, if mountain ARR.get mid is equal to target, then answer is minimum of answer and mid. So elif mountain ARR.get mid is because this is the left side, right? So if it's bigger than target, then we just do the standard binary search, right equals mid minus 1, else left equals mid plus 1. And then when we do the binary search on the right side, we flip it. So if it's too small, then we go left. If it's too big, then we go right, right? So let's do the same thing. Left and right is now peak index to mountain ARR.length. Was it length? Yeah, length minus 1. Okay, same thing. While left is less than or equal to right, mid is left plus right 2. If mount, we just copy this. Same thing, except we flip it, right? So left equals mid plus 1, right equals mid minus 1. Okay, cool. But what if target is less than the peak value? Or target is bigger than the peak value? Well, in that case, if the target is bigger than the peak value, well, it's not, because the peak value is the peak value, right? So we can just return answer here at the end. So let's go ahead and run this. Might have been some errors there. Maybe we break because we found it. Okay, cool. So if answer at the end, because if we found the peak value, because there's only one, it's always ascending, strictly ascending order from left to right, right? So there are no duplicates. So if answer is equal to float of infinity at the end, then we can just return -1 because there is no answer. Okay. Peak index. Let's see. Okay, so in the other case, otherwise, let's do another binary search, because this is, okay. Is, oh, sorry, is bigger than or equal to 0. That's the left-hand side, right? So, okay, cool. So almost there. As you can see, the last thing to do is to optimize this just a little bit. Use this. Okay. Still too many calls. Okay. It's too big. We flip it around. So 1. Okay, so this is the challenging part. Maybe we do this. So if it's equal to, then good. Okay, so maybe we can just say if value is equal to target, then answer is minimum of answer and mid, and then break. Nope. Okay, this is so if value is equal to target, then again, 1. Oh, Lord. Okay. Okay. Maybe this is better. Okay. Cool, there you go. Passes all test cases. So again, you can, small optimization there. So it's actually really efficient. So I'm pretty surprised because again, I came up with this on my own without any assistance. So pretty happy about it. Again, just ascending, descending, regular binary search, flipped around binary search, and you should get it. So that's it for this video. Thank you for watching and stay tuned for more.